On October 24, 1861, California Chief Justice Stephen J. Field sent the first transcontinental telegraph message to President Abraham Lincoln in Washington. The line had been completed just hours earlier. For 4 months, two construction crews had worked toward each other across unmapped terrain with no ability to communicate, and the final connection happened in Salt Lake City within miles of the planned meeting point. What followed was not a triumph of ambition. It was a logistics operation constrained by wire resistance, pole scarcity, and the physics of electrical transmission over distances no one had previously attempted on land. Fact 1. The route required 27,500 poles, but 1,400 miles of the path crossed treeless plains. Pole logistics dictated construction speed. In forested regions, California's Sierra Nevada and the Eastern Rockies, crews cut lodgepole pine on site and achieved 15 to 20 miles per day. Across Nebraska, Wyoming, and Nevada, there were no trees. Poles had to be hauled by wagon from distant forests or purchased from contractors who transported them hundreds of miles. Each pole weighed 400 to 600 pounds and needed to be set 4 feet deep in soil that ranged from hard-pan clay to loose sand. Western materials were shipped by sea around Cape Horn to San Francisco, then hauled eastward by wagon over the Sierra Nevada. In treeless sections, the pace dropped to 3 to 5 miles per day. Pre-positioning pole supplies became the primary scheduling constraint. The entire project planted 27,500 poles holding 2,000 miles of single-strand iron wire. Fact 2. Construction crews worked from opposite ends with no real-time coordination. The Eastern crew began in Omaha on July 4, 1861, moving west. The Western crew began in Carson City, Nevada, moving east. The two crews had no way to communicate until the line itself closed. Scheduling relied on pre-agreed daily mileage targets and supply depot locations marked on maps that were often inaccurate by 10 to 30 miles. If one crew outpaced the other, it risked exhausting pre-positioned supplies and stalling. The Eastern line reached Fort Laramie on August 5th and Salt Lake City on October 18th. The Western section completed on October 24th. The actual meeting point was within a few miles of the surveyed target, but this required both crews to maintain pace across 4 months with no ability to adjust coordination. Fact 3. Insulators had to survive temperature swings from -30 to 110 degrees Fahrenheit without cracking. Glass insulators were standard in humid eastern climates, but they shattered in the temperature extremes of the Great Basin and high plains. The specification shifted to iron holders embedded in glass, enclosed in wooden forms. These insulators had thicker walls and a design that shed rainwater to prevent tracking, electrical discharge across wet surfaces. Even with redesign, insulator failure rates in the first year exceeded acceptable thresholds. Each failure required a crew to locate the break, climb the pole, and replace the unit. In winter, frozen insulators cracked when wire tension shifted during thermal contraction. Lightning strikes destroyed sections during summer storms, creating ongoing maintenance demands that consumed significant labor. Fact 4. Relay stations were spaced by battery range, not geography. Transcontinental transmission required intermediate relay stations where operators received incoming signals and retransmitted them at full strength. Station spacing was determined by battery power limitations, approximately 20 miles under typical conditions. This put relay stations in operationally inconvenient locations, midway across deserts, at high-altitude passes, in regions with no existing settlements. Each station required a 2-person crew working 12-hour shifts, a battery bank, spare wire and insulators, and food supplies for weeks. Batteries were shipped as powder in containers with electrodes, then activated with water at the station. Wet cells provided power over these segments, and operators manually relayed each message to the next station. Resupply logistics often dictated station placement as much as electrical range. Fact 5. Wire splicing was the primary failure mode after completion. Telegraph wire arrived in reels, and every splice was a weak point. The standard technique used overlapping wire ends wrapped together and soldered. Solder joints were vulnerable to oxidation, thermal expansion mismatches, and mechanical fatigue from wind-induced vibration. In the first 6 months of operation, splice failures accounted for a substantial portion of line outages. Replacement splices used modified techniques, copper sleeves crimped over both wire ends then soldered. This distributed stress over a longer joint and reduced the failure rate, but required crews to carry crimp tools and portable forges for field repairs. Galvanized iron wire of the best quality was specified for the line, but corrosion remained an ongoing problem. Fact 6. Electrical grounding used the earth as a return path, but soil conductivity varied by orders of magnitude. The system was single-wire ground return. Current flowed out on the wire and returned through the earth via grounding rods at each station. In regions with moist, mineral-rich soil, grounding resistance was low. In the Nevada alkali flats and high desert, dry soil and low mineral content pushed grounding resistance higher, weakening return current and reducing signal strength. Stations in poor grounding zones required multiple deep grounding rods driven into moist subsoil or connected to metal plates buried in wet clay. Some stations in the Great Basin required grounding systems with hundreds of feet of buried wire to achieve adequate conductivity. Low humidity in the western regions actually provided an advantage. Low leakage allowed wet cell batteries to transmit over longer distances than in humid climates. Fact 7. Maintenance crews faced attacks and environmental sabotage. Keeping the line operational faced multiple problems beyond weather. Bison rubbed on poles and brought down sections of wire. Native American groups cut sections of the line during hostilities with the Army. In one incident, Sioux warriors removed a significant length of wire to make bracelets, though attacks reportedly decreased after some who wore the wire bracelets became sick, and their medicine man attributed it to the spirit of the talking wire. The system had to be rerouted through Chicago to avoid Confederate attempts to cut the line in Missouri to disrupt Union communications during the Civil War. Each disruption required crews to locate the damage, transport materials to remote locations, and restore service while exposed to the same threats. Fact 8. Message costs were designed to generate revenue, not accessibility. The Telegraph Act of 1860 specified a rate of 30 cents per word, but financial reality demanded higher prices. During the first week of operation, Western Union charged $1 per word. Later, this was adjusted to $7 for 10 words. Compare this to the Pony Express, which charged $5 per half ounce initially, reduced to $1 per half ounce by July 1861. For a 10-word telegram at $1 per word, the Telegraph cost $10 but delivered in minutes, rather than the Pony Express's 10 days. The economics were straightforward. The Telegraph's infrastructure cost was higher, but the marginal cost per message was near zero once the line was operational. The system was financially successful from the beginning, despite the high construction cost of $500,000. Fact 9. The line was operational for 8 years before being replaced. By 1869, iron wire corrosion, insulator degradation, and splice failures had accumulated over nearly 8 years of operation. The Transcontinental Railroad was completed in May 1869, and a multi-wire telegraph system was constructed alongside the railroad route. The original 1861 line's primary value was not longevity. It was proving that transcontinental telegraphy was operationally viable and generating revenue that funded expansion of the telegraph network. The line served through the critical years of the Civil War, when instant communication between Washington and California was essential for maintaining Union loyalty in the western states. The replacement system used improved materials and followed the railroad right-of-way, providing easier access for maintenance. Fact 10. The Pony Express ceased operations 2 days after the telegraph opened. On October 26, 1861, the Pony Express, which had operated for 18 months carrying mail across the same route, ended service. The economics were straightforward. A Pony Express letter cost between $1 and $5 per half ounce and took 10 days. A telegraph message cost $7 for 10 words initially, later $1 per word, and arrived in minutes. The Pony Express had always been a financial loss, subsidized by the hope of a federal mail contract that never materialized. The telegraph eliminated the only advantage the Pony Express had: speed relative to alternatives. The faster system required no horses, no relay stations with fresh mounts, no riders. It required only wire, poles, and operators. The infrastructure cost was higher, but the operating cost per message was dramatically lower. If you want more breakdowns of engineering systems that operated at the edge of what was possible, subscribe to Grandeur Decoded.